All right, welcome back. Let's see here. We're continuing with our simple machines, and today we're going to basically be taking a look at mechanical advantage. Now, what is mechanical advantage? Mechanical advantage is how many times a machine multiplies your force. You put a force into a machine, many times that force will be multiplied. Sometimes it could be multiplied by a decimal, making it actually harder to move, but it's multiplied by something, okay? We're going to use, I'll put down a few formulas first, I guess. So, mechanical advantage. If you want to figure out the mechanical advantage of any simple machine, all you have to do is take the output force, the force coming out of the machine, and divide it by the input force. And that'll give you how many advantages you have, how many times your force, your input force, is multiplied to get the output force. Now, say we didn't have that. What if we wanted to figure out the mechanical advantage of an inclined plane? Well, then you take length of the plane divided by the height. That'll also give you the mechanical advantage, but that one only works for an inclined plane. This is the one that we're going to use, the mechanical advantage of a lever. To get the mechanical advantage of lever, that's going to be the effort arm divided by the resistance arm. Okay? So, let's go ahead and take a look at this sample problem. I have an 8-foot long 2x4, pretty standard Home Depot type. I'm going to make a first class lever with it. I pulled the fulcrum 2 feet away from the load. So let's just go ahead, let's draw a nice little picture here. There's an 8-foot, the whole thing is 8 feet long, okay? I'm going to put the fulcrum right here. This is 2 foot long from the fulcrum to the load, okay? So 2 feet long right there, 8 foot total. That tells me that from here to here, my effort arm from the fulcrum to where you're pushing on it, that's the effort arm. Effort arm is going to be 6 feet. Now I should also say from the fulcrum to the resistance, that's the same thing as the resistance arm, and that's 2 feet in this case, okay? I can push it down to the maximum of 450 newtons. Let's say I weigh 450 newtons and I put all my weight pushing down on it right there. What is the heaviest load I can lift, assuming that my 2x4 doesn't break, okay? So it's basically saying, what's the biggest load that I can put right here? Well, let's start out. Let's figure out the mechanical advantage of a lever. The effort arm, the length of the effort arm in this case is 6 feet. Now, I'm going to leave it feet. Usually we work only in metric units in science class. I'm going to leave it in feet because in this case it's not going to matter what units I have it in as long as I have it in the same units on the bottom. The resistance arm. Resistance arm is from the fulcrum to the resistance. In this case it's going to be 2 feet. Okay? Now you can just see the labels here, they cancel right out. 6 divided by 2 ends up being 3. So my mechanical advantage is 3. I like to put a little X there just to remind me that that means that whatever force I put in will be multiplied by 3. Okay? It'll make it like I'm 3 times stronger. Now, back to the question. Alright, what is the heaviest load? What's the biggest thing right here that I could put? Well, I can put in 450 newtons of force. This thing's going to multiply it by 3, so all I have to do is take 450 times 3, and I could put up to a 1,350 newton load on this side, okay? Any force I put in will be multiplied by 3. I can only, I'm maxed out with 450 newtons. That means I could put up to a 1,350 newton load on this side. Now, I might need a little bit extra oomph to get over the inertia, but you guys get the basics of how to do these. Hopefully mechanical advantage makes a little bit more sense, and have a great